Use ever gazed up at the sky and seen a massive metal bird soaring effortlessly through the clouds? It seems almost magical, right? How does a machine that weighs hundreds of thousands of pounds actually get off the ground and stay there? Well, it's not magic, it's science. And today, we're going to demystify the incredible physics of flight. So buckle up, because we're about to take off on a journey to understand how airplanes work. First things first, we need to talk about the 4 fundamental forces of flight. Think of these as a constant tug-of-war acting on the airplane at all times. These forces are lift, weight, thrust, and drag. For an airplane to fly, these forces have to be in a delicate balance. Let's start with weight. This one's easy, Tritz. Simply the force of gravity pulling the airplane down towards the center of the Earth. Well, everything has weight, from the plane itself to the passengers, the luggage, and the fuel. The entire goal of flight is to overcome this force. So, how do we counteract weight? With lift. This is the upward force that pushes the aeroplane into the sky, and it's generated primarily by the wings. This is where things get really interesting. An airplane's wing isn't just a flat board. It has a special shape called an airfoil. It's curved on the top and flatter on the bottom. As the airplane moves forward, air splits to go over and under the wing. Because of the curved upper surface, the air traveling over the top has a longer distance to cover to meet up with the air from the bottom at the same time. To do this, the air on top has to speed up. Now, a very smart scientist named Daniel Bernoulli discovered something crucial. He found that the faster air moves, the lower its pressure. So, we have fast-moving, low-pressure air above the wing, and slower-moving, higher-pressure air below the wing. This difference in pressure creates a net force pushing upwards. That's lift. The higher pressure underneath literally pushes the wing and the entire plane up into the air. It's like a giant, invisible hand lifting the plane. Of course, to generate this lift, the plane needs to be moving forward. That's where our third force comes in, thrust. Thrust is the force that propels the airplane forward through the air. On most modern airliners, this is generated by jet engines. A jet engine works by sucking in a massive amount of air at the front. Inside, a series of fan blades called a compressor squeezes this air, making it very dense and hot. This compressed air is then mixed with jet fuel and ignited. This creates a powerful, controlled explosion that shoots hot gases out the back of the engine at extremely high speeds. Thanks to Newton's third law of motion for every action, there is an equal and opposite reaction. As the gases shoot backward, the engine and the airplane attached to it are pushed forward. It's this powerful forward motion that keeps air flowing over the wings, continuously generating lift. But as the airplane surges forward, it encounters our fourth and final force, drag. Drag is the resistance of the air pushing back against the plane. It's the same force you feel when you stick your hand out of a moving car's window. It wants to slow the plane down. Everything creates drag, from the fuselage to the tail fin, and even the antennas. Aircraft designers work tirelessly to make airplanes as streamlined and aerodynamic as possible to minimize drag. A sleek, smooth shape allows the air to flow over it with less resistance. So, for an airplane to maintain a constant speed, the thrust from the engines must be equal to the force of drag. To accelerate, thrust must be greater than drag. So let's recap the balancing act. In straight and level flight at a constant speed, lift equals weight and thrust equals drag. The forces are all in harmony. But what about maneuvering? How does a pilot actually control this giant metal bird? This is done by using control surfaces on the wings and tail. Let's start with the wings, too. On the back edge of the wings, you'll find hinged sections called ailerons. The ailerons move in opposite directions. When the pilot wants to roll the plane to the right aileron goes up and the left aileron goes down. The upward aileron decreases lift on that wing, while the downward aileron increases lift on the other. This imbalance causes the plane to roll or bank to the right. Now for the tail. The horizontal part of the tail, called the horizontal stabilizer, has hinge sections called elevators. The elevators control the plane's pitch, which is its nose-up or nose-down movement. When the pilot pulls back on the control column, the elevators go up. This pushes the tail down and causes the nose to pitch up, making the plane climb. Pushing the column forward does the opposite, making the plane descend. Funnily, the vertical part of the tail, the vertical stabilizer, has a hinge section called the rudder. The rudder controls yaw, which is the side-to-side movement of the plane's nose. When the pilot pushes the left rudder pedal, the rudder moves to the left. This pushes the tail to the right, and the nose yaws to the left. The rudder is mainly used to make small corrections and to keep the plane coordinated during turns. So, the pilot uses a combination of ailerons for roll, elevators for pitch, and the rudder for yaw to expertly guide the aircraft through the sky. But there are other clever devices on the wings, too. During takeoff and landing, when the plane is moving slower, it needs to generate more lift. To do this, pilots extend special surfaces called flaps and slats from the front and back edges of the wings. These devices temporarily increase the wing's surface area and its curvature. This allows the wing to generate enough lift to take off at a lower speed and to fly safely at the slow speeds required for landing. Once the plane is up to cruising speed, the flaps and slats are retracted back into the wing to reduce drag and improve efficiency. From the first powered flight of the Wright brothers to the supersonic jets of today, the fundamental principles remain the same. It's a beautiful symphony of four forces, ingeniously controlled by human innovation. It's the airfoil shape creating a pressure difference for lift. It's the powerful engines generating thrust to overcome drag. And it's the precise movements of the control surfaces that allow for graceful navigation through the air. So the next time you're on a flight, peering out the window as the ground shrinks away, you'll know exactly what's happening. Throb magic, but an amazing application of physics that allows us to conquer the skies. You're riding on a cushion of high-pressure air propelled forward by controlled explosions, all in a delicate high-speed ballet of forces. It's a testament to human ingenuity and our endless curiosity to explore the world around us. Thanks for joining me on this deep dive into the world of aviation. If you found this fascinating, be sure to hit that like button and subscribe for more videos where we break down the science behind our amazing world. Fly safe and see you next time.